So what we have completed in the previous class? So we wanted to write out the vector formula of the force. Yes, vector form of the Coulomb force. So we said that it will be equal to Q1 Q2 by R square RK. That's what we said. So you can say that force on first charge due to second charge. Q1, Q2 were the two charges. Force on second charge due to first. Both are positive charges, so obviously it will be a repulsive force. A Q1 Q2 by R square R1 to 3. R1 to means the unit vector in this direction from 1 to 2. The unit direction in the direction of 1 to 2. That is the force on the second charge due to first. That is right R21 also. So that will mean the same thing 1 to 2, but let's write it 2 1 so it will match with this one. So it will be easier to remember. This is just notation, you can write any way you want. So then R21 vector will be what? The position vector from what? Sorry, the displacement vector from 1 to 2. The displacement vector from 1 to 2. right? Then we use the vector triangular addition, right? In the previous class to find out R21 vector will be equal to R2 vector minus R1 vector. We use triangular law of addition, vector triangular law of addition in order to find out the R21 vector. Got it? In the previous class we have done that. So now what we can do is we can write this formula F1 equal to this Q1 Q2 by R. This is actually R2 minus R1 mod Q, because that is the distance between Q1 and Q2, right? R2 minus R1. This is R2 minus R1, right? That's what we have found. R R21. So that will be the formula, but now you need the direction also. So R21 cape. And I told you that unit vector is written as R21 vector divided by R21 magnitude. Vector. So vector will be the same here like this R2 vector minus R1 vector divided by R2 minus R1. That is the definition of a unit vector. All of these things we have covered in the initial classes, right? The unit vector it is. So unit vector will be written as vector divided by vector magnitude. But still, if you do not understand anything, you can ask me the question. Okay, we have covered all these things, but still, if you do not get anything, ask me. So Q1 Q2 divided by R2 by 2 minus R1 vector mod Q, because 2 and 1 Q it will become R2 vector minus R1. That will be the force on second charge particle due to first charge particle, and that is the vector notation of Coulomb force. There is a one important thing about this vector notation. If there is any charge which is positive or negative, you will put those signs here. If the charge is positive, you will put positive. If charge is negative, you will put negative. So you can check if one charge Q1 is positive and Q2 is negative. So what would you get? F21 vector you will get as minus sign will be there. So KQ1, Q2, this, right? There is a negative sign due to this negative Q2 charge that will be absorbed in this. Means this will become R1 vector minus R2 vector divided by R2 vector minus R1 vector. This is done because this is a negative sign, this is positive, so this will become positive, this negative, and this negative I have taken inside the bracket. I multiplied negative 1 to this, so you got this. Okay, so that will be actually, now what will be the direction? What will be now the direction? The direction will be opposite, right? Okay. So that is true when the two charges are negative. Sorry, one charge is positive and one is negative. You can see one more thing also, that if that force that we have written between these two Q1, Q2 charges. So I have written force on Q2 charge due to Q1, so that will, and that was in this direction. But what if I write force on Q1 charge due to Q2 charge? So that will be in the opposite direction. So that will be F1 to vector. That will become K Q1 Q2 divided by R1 minus R2 Q. This time it will become R1 vector minus R2 vector. Before, when we have written F21, then it was R2 minus R1. Now if we have written F12, it has become R1 minus R2. So these indices are followed here. You can see 1, 2, it means 1 minus 2. If it was 2, 1, it was 2 minus 1. And this doesn't matter, however you write, because it is a mod cube. So R1 minus R2 mod is equal to R2 minus R1 mod. Mod means if it is a, you have to take the modulus of a vector. R1 minus R2 calculate and take modulus of that vector. Magnitude of that vector. Okay. So that is the force in vector form. You can write that. That is important. Okay. By this value also, I don't remember if I have written this in the previous class. This is the value of epsilon naught. Now what will be the units of epsilon naught? Because the value we can remember, but remembering unit is difficult, right? So how would you calculate the unit of epsilon naught? We have done it several times, right? That's what we have done till now. Units and all. Okay. We don't know. To use this formula, the unit of epsilon naught, we can write by isolating epsilon naught and writing everything like this. Epsilon naught, write like this. So Coulomb will become Coulomb square divided by meter square Newton. This will go down. So it will become Coulomb square divided by Newton meter square. So as I said that if there were two charges Q1, Q2, so I said Q1 will apply force on Q2. Sorry, not in this direction. Q1 will apply force on Q2, that will be F21, and Q2 will apply force on Q1, that will be F12. So I guess now you can recognize the relation between F12 and F21. What is the relation? How are they related? F21 and F12? The magnitude of F21 is same and their directions are opposite. So Newton's third law. Newton's third law it is. Every action has equal and opposite reaction. So this is the action. It means this is the force applied by Q2 charge on Q1 charge. So this is the action. And then in the reaction, Q1 will also apply the same equal and opposite force on Q2. Equal means equal in magnitude, opposite means opposite in the direction. So F12 vector is equal to minus F21. That is followed by Newton's law. Got it? That is followed by Newton's third law. Every action has equal and opposite reaction.
So the value of epsilon naught is 8.85. Is it not 9.2?
That is K. That is K. K is equal to 1 by 4 pi epsilon naught. That is epsilon naught. They are different. So you understood this? Any doubt? If there is any doubt, I will describe. Even if we completed something, you can ask the doubt. I will explain that. You got it? Okay, good. So that is the force due to point charge. Mainly, what you can remember is you have to remember all of the stuff. That's what you have done that. But mainly, you need to know at least these formula because at least this formula. This is at least. I'm not saying that only remember this one. F means the Coulombic force is equal to K Q1 Q2 by R square. That you must know. Where R is the distance between these two charges and Q1 Q2 are the charges only. So at least you need to know this thing, and you also need to know that the force Q1 Q2. So the force is between Q1 and Q2. So the force on Q1 due to Q2 is equal to Q2 on force due to Q1 on Q2 is equal to force on Q2 due to Q1. They are the same force, but their directions are opposite because they will repel each other, right? Okay. Now we will discuss. Now that was about the point charge. That Coulomb force is due to point charge only. But there are extended charges also in nature, not only point charges. So what if there are multiple number of charges? So that is called the superposition law. Superposition law. That is nothing but the vector addition that we have studied. Just the addition of vectors, because force is a vector quantity, so they will be just added just like vectors. So for example, this tells that if this is a q1 charge, this is q2 charge, and this is q3 charge. If I want to find out the total charge, the force on q3 charge, the total force on q3 charge, so that will be equal to F on q3 will be equal to F. Now let me write like this. Force on third charge will be equal to force on third charge due to first charge plus force on third charge due to second charge. So this law tells you that the force on some single charge due to the other charges is equal to the force on that charge due to is equal to the summation of the force on that charge due to individual charges. So force on, just imagine on this Q3 charge, the total force on Q3 charge will be equal to the force due to each individual charges on Q3 charges and then added together. So you can see here, from this you can remember. So force on third charge due to second charge will be in this direction, and due to Q1 it will be in this direction. That is force on third charge due to 1. That is force on third charge due to 2. If you will add these two forces together, you will get the net force on third charge. And vector addition, this is just the vector addition, so you just have to add vectors. Okay. Let me give you the hint. Not hint. Let me tell you how to add vectors again. Parallelogram law of vector addition. So this will be the resultant vector. This will be actually the F3 vector, force on third charge due to all the other charges. Write it. It is very important. Superposition law. But it is very simple. You just have to add two vectors. That's what it says. So you can write like this also. There are many ways to write. Fc is equal to F3. Just imagine that there are many other charges also. Because we have to taken the example of two charges, there can be many other charges also. So force on some, say, okay, you can take three. Force on the third charge due to first charge, force on third charge due to second, third, fourth, like this. So you can say that it can be written as F3I, and there is a summation over I. It means I will keep changing from 1 to how the number of charges. That just means that F3 1, because put this I is equal to 1 first, then add. That's what this symbol means. Then F put 3 2 and add. F3 put 3 add, like this. This is how you can keep adding for n number of charges. In this example, n is 2. It means we took only 2 charges. Hello. Yes, yes. So that is the vector addition of forces. Now, you know that what is F31, you can write, right? K Q1 Q3 divided by R3 minus R1 mod Q R3 minus R1. That was a formula. So you can write like this also. Because the 3 is not changing, other indices are changing. So you can say K I K Q1 K3 K2I divided by R3 minus Ri vector mod Q R3 minus Ri vector. So that in that way also you can write the total force on third charge. For n number of charges. Okay. So now we will talk about the electric fields. What is electric field? Huh? ये वाला है 7:30. हाँ. तो ब्रेक के लिए. हाँ हाँ 2 5 मिनट का. तीन चार हैं? अच्छा electric field. So electric field is defined as force divided by charge.
Like this particle experience the electroelectric.
Hmm?
But the particle experience the electrostatic force.
Yeah, yeah, you want to say that electric field is something due to which the other charged particle experience the force. Yeah, very good. That's it. E is equal to F by Q. So, for example, you can understand electric field as an influence of a charge around it, around its space. Okay. So, in that influence, if some other charge is going to come, then it will get reflected or attracted depending on the charge signs. So, for example, if this is the capital Q charge and there is and we want to calculate the electric field of this. Okay, if we want to calculate the electric field due to this capital Q charge, so what we will do is just wait for 5 to 10 minutes. Okay, there is just urgent meeting and then we will continue on. Okay, in this time what you can do is, because we have covered the force, right? So you can calculate the force plus Q minus Q on this charge. Small q. This distance is R, this distance is T. Okay, you need to write the force on small q charge due to this plus Q and minus Q charge using the superposition principle. Okay. What's that? What's that?
బియ్యం కావాలా? గూగుల్ ఫోటో తీసుకున్నా.
ఇది 1/4 epsilon naught. बताओ तो रही है ना तो
So, what's your answer?
But that is different view and that is different view.
Yes. So when I ask question, then you heard out. Okay. So take it as homework. Let me complete the topic first, and then we will go over that question also. Okay. I want to complete the topic. Or let me write the solution. See, this is negative q charge. There is this small q charge, right? So the force between these charges, like force on this small q charge, will be k q by d square is the distance. In which direction? It is going to attract. So in the left side, right? Or you can say in the minus side. So it will be minus. Then force between this charge and this charge, small q. So this will be k capital Q small q divided by what is the distance between them, r plus d, and that will be in the positive side. This is the answer. Just have to write the formula exactly. Okay.
Sir, I have a doubt.
Mm-hmm.
Sir, why is it minus sign?
Because it is a vector quantity, and this vector is directed in negative direction.
Sir, why is it in negative direction?
We have studied vectors, right? We have discussed vectors.
Yes,
So
sir,
if
but
we
I
will
didn't
keep
understand in
discussing
this
the same
case.
thing, if I will keep discussing the same thing, how will we progress?
Oh, okay, sir.
This is negative x, positive x, and positive y, negative y. So this is the Cartesian coordinate system, and if some vector quantity is in this side, so we write negative. If some vector quantity is in that side, then we write positive. We have done that, right, in the vectors.
Yes, sir. Yes, sir.
We spent the previous days just on these topics, vectors, so we do not have to spend time when we are discussing the 12th class. That's what I said.
Yes.
So revise the part that is completed. That's what I said, that you won't understand from the 12th class if you will not understand now the portion of 11th. That was portion of 11th, right? But that time you were asking me, sir, when would you start 12th class? Now you are asking me 11th class. I'm not saying that you cannot ask the doubt. You can obviously ask the doubt. That is good. Even now you can ask. But please revise whatever is done. You haven't paid attention when I was doing vectors and all. That's pretty much clear, right? Because none of you know, not only about her, none of you know how to add vectors, still how to subtract vectors. Otherwise, that was the question, this question. I said that even in the 12th class, there is electrostatics, but you will need vectors. You have to add vectors, have to. I told it many times, but none of you have learned them. When I used to ask that, have you revised this topic? Then you were literally saying, no, sir. Right? So that is not the, I'm saying that's not the end. Still, you can revise the stuff that is taught, because you are going to face problems otherwise if you will not know the vectors, right? So for example, if you do not know how to add two things, how would you learn the mathematics, right? So you have to keep clearing the basis, then only you can learn the specific things. So please revise whatever is taught. Okay, that is very important. That's very important. Vectors and all these things, units, vectors. Okay. So we were discussing electric field. Electric field I defined as force divided by charge, and then using this formula, we know that force between two charges. So using this formula, we will calculate electric field due to a point charge. So for example, this is a point charge capital Q, and there is a small q charge, you can say, and the distance is r. So it is very simple. And these are vector quantities. Electric field and force, both are vector quantities. So force between them is K small q capital Q divided by R square. That is the force. Now divide it by the charge and you will get electric field. So if you will divide it by this charge, now you have to divide by the another charge, this charge. If you are calculating electric field due to this capital Q charge, then you have to divide the force by the other charge, leaving this capital Q. Okay, so small q will get cancelled and you will get kq divided by r square. That is the electric field. Kq by r square. That is the magnitude of electric field, and the direction of electric field will be the same as the direction of F if the charge is positive. But if the charge is negative, then you can see that the force divided by minus q it will become, right? So then it means if there is a negative sign here, it means the direction of electric field will be opposite to the force because there is a negative sign. Okay. Understand? So because the direction of force was in the radial direction for both of the positive charges, so E vector can be written as KQ divided by R square R cap. It means along the line. Along the line, the direction will be.
Tomorrow at 11:30. First class will be half an hour late.
Okay. E is equal to KQ by R square R cap. That is the vector form of electric field. Now,
Someone told I call it
someone.
Someone told I call it cancer.
Oh. So be careful. So that is electric field. You can add two electric fields just using the same formula as you added force. Superposition principle. Because electric field is also a vector quantity. So if you want to add electric field due to this capital Q charge and small q charge, and at this point, so you will add electric field due to this capital Q and small q using the same formula, the superposition principle. E1 vector plus E2 vector. Here the electric field will be this, electric field will be this. Then you can find out the resultant. This will be the total electric field. Understood? So that is just the simple. If there are two charges, then write their electric field, they are vectors, and add two vectors. Now let me tell you about the direction a little more. If this is a positive Q charge, and at this point the electric field direction will be this. Okay, it means outward, just like spreading like this. Spreading like this. At this point it will be in this direction, at this point it will be in this. So these are the field lines due to positive Q charge. Due to negative Q charge, field lines will be like this. Inwards. Very good. The field lines will be inward due to negative charge. Due to positive charge, they will be out. You can write them, but the directions are very important. So at least you should know the direction of electric field and the formula of electric field due to a point charge, which is KQ by R square. Okay, these two things are very important here. And there is one more thing, when we write this E is equal to F by Q, then this Q charge is very small. This Q is tends to 0, you can say. It is very small charge because it is just a test charge. Because there is a capital Q charge put here and it has some electric field. Okay, and we want to test this electric field. So we will put a test charge Q. So that will feel a force due to this Coulombic repulsion. And that is how we are going to measure the electric field. But this charge must be small because so we do not get the effect of the small q charge involved in this. So we do not get the effect of the small q charge involved in this. That's why we consider it small charge.
Small q is also the force, right?
Hmm?
Small q is for force.
What force means?
Small q is used for force, right?
Yeah, you can use any charge for force. K q small q by r square. That will be the force between these two charges. But if you want to calculate electric field due to capital Q charge, then you will divide it by small q, and this will become electric field. Is it clear? So let me, in summary, let me tell you a little bit. In summary, if you cannot remember all of the data, then at least like even if you can remember all of the data, what I mean is that these are most important things that I'm going to write. So the formula of the force. So this you should remember. You should remember all of the things, but these are most important ones. It means they must be in your head. And electric field will be kq by r square. That is the electric field at r distance away. And you can write the direction also if you want. And the relation between electric field and force. Now this formula can be written in this way also. F is equal to EQ. It means if you know the electric field sometimes at some distance and then there is a charge there, so you can calculate force on that charge also. So force on some charge small q will be equal to electric field at that distance at that point into that charge itself. Okay, that is the electric field. Now we will talk about the flux. Can you tell me what is electric flux? No? So
Then the number of lines passing through some point,
no, passing through, very good, like it's good.
passing through some electric
Passing through surface, good. So flux basically tells you that how many number of field lines are passing through a particular surface. Okay, that is what the flux is. So there are two key points here: the electric field and the area. These two things are required. So for example, if these are field lines and this is the surface, this is electric field, this is surface, so S vector. This is a uniform electric field, that's why electric flux will be equal to E dot S. This is the formula for the flux, E dot S. What is the meaning of E dot S? What is the formula for the dot product?
AB cos theta.
Yes, good. AB cos theta. So it will become ES cos theta. Good. So if you can remember the previous stuff, it will become very easy. That these things are very easy. We introduced only two new things here: the formula of the force and the formula of electric field. Right? Other things were just vectors, vector addition, dot product, all the things that we have already completed. So if you know the details of that, then it is very easy. So phi can be written as ES cos theta, where theta is the angle between E and S. So here, let me tell you, the area vector is always perpendicular to the surface. That is something that you need to know, that area vector is always perpendicular to the surface. So this is perpendicular to the surface and electric field is also in this direction. So angle between E and S will be 0. So this will become just ES for this one. But if the electric fields are at some angle, this will be the area vector because it is perpendicular to the surface. If electric field lines are like this, then what you will do, you will take this angle between E and S and you will write flux is equal to E dot S, means ES cos theta. Electric field at these points, electric field at those points exactly, into the area and cos theta. So when you are writing electric flux through the surface, then you have to write the electric field exactly at those points of the surface. And you have to multiply that with the surface. That is the formula of the flux. Right, this part, flux is very important. But in this, we have considered the electric field uniform. Sometimes what can happen is For example, if there is a surface like this and charge Q is put, so electric field will be different, right, at the disk, because this distance is different than this distance. You can see this is a hypotenuse and this is base. So this distance is different than this distance, and we know that the electric field formula contains R, means the distance. If the distance is different, it means the value of electric field is different at the points of this disk. So, and we need the uniform electric field here. So what we will do instead, we will write the electric field at this point only, and we'll write the area vector. This is theta, this is theta, and we will say E dot del S, because this small area is del S, right? Del S means small area, smaller in the size, infinitesimal area, where you can consider that all the field lines are equal in very small area. So this will become the flux throughout the surface only. But what will be the total flux? You will add these together, right? If you will add these together, you will get the total flux. So phi, total flux, that you can write as del phi. Total flux will become summation of E dot del S. Addition of all these, like here you will consider here. All these things must be added. So E dot del S is the flux through a small infinitesimal area. Okay, and then you will keep adding these fluxes at different areas of the disk, and that will become the complete total flux throughout the disk. That is called the total flux, E dot del S summation. So that is also one of the important formula of the flux. This flux tells you that how many field lines are going through the surface. What is the electric dipole? Hmm? Two opposite charges separated at some small distance. Two opposite charges separated by some small distance are called the electric dipole. Because it has two poles, one positive pole, negative pole. That's why it is called dipole. The dipole moment of this electric dipole is defined as QD. One charge multiplied by the length of the dipole. So just have a break of 2 minutes, then we will continue. Okay. So join after 5 minutes. Okay. It is morning. Yeah. Okay. So, should we start? So this is electric dipole. Flux you understood, right? Remember two things: electric field and area. Electric field will be passing through the area. That is the flux. Electric dipole moment or electric dipole. Two charges, two opposite charges and equal and opposite charges separated by some distance, small distance. That will be the electric dipole because it has two poles in it, right? And there is a distance between them. Dipole. You might have seen these dipoles in chemistry also, right? There are dipoles in chemistry because they have the opposite charges, so that's why that is a dipole. Dipole moment is a physical quantity that can be written as q. It means one charge into the distance d. Now we will study the electric dipole in external field. Electric dipole in external fields mean there is external electric field. Okay. For example, this external electric field is there. And there is an electric dipole in this electric field. This is electric dipole. The distance between that, the length of the dipole is d. And there is one more thing also. If there is a electric dipole minus q, positive q, the direction of this dipole moment will be negative to positive because it is a vector quantity. P is equal to q d. Okay. So QD you can say n cap, where n cap is in the direction of negative to positive. So here also you can say that the direction of this will be this P. Just say P cap you can say. The direction of P is P cap, unit vector. And we are saying that this angle is theta. Angle between electric dipole and field is theta at some moment. So for now, for example, as I said that the force can be written as QE vector, right? So if it is a positive charge, then force will be in the direction of electric field. If it is negative charge, then you have to write negative QE. So the direction of force will be in the opposite direction of electric field. So here the force on this negative charge due to this electric field will be in this opposite side of the electric field, and on the positive charge it will be in the direction of electric field. Does it make sense? Because from here. So, and how much force is there? QE. QE. So you can see that there are two equal forces in the opposite direction, right? So they should, yes, can, that is right. No, can was right. After can, they cancelled. The force will get cancelled, right? So can was right. That's what I said. Cancelled, okay? Because the question was this, that there is a force QE, right, in that side, in the negative side, you can say, and capital positive QE in the positive side. So they are same force in the opposite direction, so they should cancel each other. So the net force on the dipole is 0. But still, okay, for example, if hold your pen, apply the force on the pen in this direction and apply force on the pen in this direction.
It rotates.
Yes. Right? So it will rotate. It means that the net force is zero, but it will rotate, right? Why does it rotate if the net force is zero?
Because the pole factor of the opposite directions.
Good. Huh?
Opposite direction.
Yeah, force. There are two forces in the opposite direction. Yeah, that was good. That is due to that was rotation, right? Yeah. So you are applying torque on that pen. That's why that is being rotated. So here also there is a torque on this pen. Now you are looking at my face. Yes, sir, what is the torque? What is torque then? Tell me. The torque is defined as R cross F. It is also called the rotational force, or the moment of force. It means if we want to displace something from one point to second point, then we have to apply force. But if we want to rotate something, then we have to apply torque. Okay. So that is the torque. And this is cross product, so it can be written as Rf sine theta. And n cap will be the direction. But if you just write the magnitude, then it will become Rf sine theta. Theta is the angle between R and F. Force and radial distance. For example, n cap. Yeah, n cap I removed because it is just magnitude. That is the vector. The direction n cap you can find by using your right hand thumb rule. Curl your finger, put your fingers in the direction of R and then curl them in direction of F. So your thumb will be telling you the direction of the cross product or torque. Okay. Right hand thumb rule. So that torque is working on this dipole also. Okay, so let me tell you about the torque a little bit. I already described that, but just for this topic, if this is the origin, this is the R distance, and force on this object is this. On this body, force is this. F vector. And R vector is the position vector of that body from the origin. So what you will do, as I said, you will extend this vector like this. You will find this angle theta, and the torque will be defined as Rf sine theta. That will be the torque. So that is the formula of torque. Okay. So now we need to calculate the torque on this dipole. That is the problem. So there are two forces working here, right? So for example, you can say that this is the origin. Just say that this point is the origin. Oh. Now there are two forces. One force is QE. So what is R for QE force? 0. Because this R is actually the distance between the origin and force, right? Where the force is being applied. R is the distance between the point, origin, and the force, where the force is applied. So what here, if I consider this origin, if this point is origin, then force is also applied at this point only. So the distance will be 0 between this point and where the force is applied. So due to this force, the torque will be 0. But there is this force. That distance is not 0, right? This is the origin and this is the force. So the distance between this point and this point is D. So, okay, D. But this D will be in this direction. As I said that we will extend it. R, that is R vector, position vector, R cross F. So this R vector will be equal to dpk, because the direction is this pk, rpk. D is the magnitude, pk is the direction. Now the force is this QE, and what is the angle between? Theta. If this angle is theta, so this angle is also theta. So it will become D QE sine theta. R is equal to D, F is equal to QE, and sine theta is sine theta. That is the torque. That is the formula we used. So this dq can be written as the dipole moment P. E sine theta. That is the formula of the torque, and it is very important. This can be written as torque vector equal to P cross E also. The same thing, right? Because P cross E is P sine theta. And here also you can write the direction. The direction will be the same as P cross E. So that is the electric dipole in external electric field. That is the formula of the torque on that dipole, electric dipole. Can anybody tell me that why is this handle at that location? Why is this handle of the door is at that location? Why isn't it at the middle? If there is a door, then you see that always the handle is here. The handle is not here. The handle is not in the middle. In the middle, it will look good, right? Like just in middle.
For more
Symmetry.
You should put more force to pull it.
Very good. If it will be in middle, then you have to apply more force. Can you rotate this door by applying force on that point? Why is why is that the case? Not fixed that side, like that glass part is there, right? So you can go and try rotating that. Can you rotate it by just a finger? And if you apply a force by finger on that side, then on the handle side, then you can rotate. So what is the reason? Haven't you thought about it? You have thought about it. Then what did you thought? What did you think? No, like you can, if the distance is less, then force is not less, right? We are applying use force, but the door is not rotating. If the door is not rotating, does it mean that I am not applying force? For example, I am applying force on this wall because it is not moving, it means you are not applying force. Force you are applying there only, but it is not rotating. What is required in order to rotate something? Torque. So it means torque is less there, not force. Because torque is equal to R cross F. R is the distance. This is the R. And the force you are applying is F. This is the R. If this R is greater, the torque will be greater because torque is equal to RF sine theta. So if R is greater, torque is greater. If R is less, torque is less. If torque is greater, then door will rotate. If torque is less, then door will not rotate. Got the point? So that is the case here also. That is the torque, P cross E. I just tried to make you remember the formula RF sine theta. This is the torque on this electric dipole due to the external electric field. It is very important formula. You will remember that. Torque is equal to P sine theta. Just write that and then we will cover the next topic. That will be the Gauss law. Is Gauss law completed in your schools? Okay. So now you will answer, right? No, you want? Even if it is completed? Didn't understand. Now you're understanding the torque. The torque you understood? The door and all these things? %10 only. 90%. That's good. There is one more thing also before discussing Gauss law. We will calculate the force. So we will calculate the force due to the dipole, electric dipole. So at 2 points we will calculate the force. At the in this axis of this dipole and at that point, perpendicular to the dipole. But the force you can calculate, right? I told you the formula. And I also explained how to calculate force at some point. So for example, just say that at R distance away you want to calculate the force. At R distance you want to calculate the force. So the force, you have to put a charge, of course, or the electric field we can calculate, so we do not have to put the charge on the electric field. R distance away, then there is the electric field. Formula of electric field is kq by r square, means the distance square. So at this point, electric field due to this negative q will be kq by r square in this direction, because the direction of electric field will be inward due to negative charge. Electric field due to positive Q charge will be radially outward. And that will be KQ plus R plus D whole square. So it will become KQ will come common 1 plus R plus D whole square minus 1 by R square. That will be the electric field. And R distance away on the axis. So it will become D square plus 2RD divided by R plus D whole square. By taking approximations, because the d distance is very smaller. Now, as we said, the d distance is very smaller, and r is larger, so it will become aq by r plus d square. Let me do it. Okay. This is how you can calculate the electric field. Okay. Now let me tell you what is the how we can write the exact formula also. We can write the exact formula. Is it completed? Okay, tell me the electric field at this point. What will be the electric field formula at this point?
It's like
That is the electric field due to
A2
that.
divided by R squared.
No, that's right. Plus two charges here. This distance from this distance is r. Where this is also 8 and this is also 8. So from this charge to this charge, the distance will be a plus r. That is the electric field due to positive charge. The electric field due to negative charge will be K2 by R minus A whole square. Now calculate and tell me this simple calculation, what will be the answer? All of you calculate. I will answer. I will ask individually what did you get. Calculate this calculation. This is a simple calculation. Do it. KQ is common, so you can write KQ here. Now we will take the approximation. This is not approximation. We already said that the R is very greater compared to A. So now we will take approximation here. If R is very greater than A, it means A will be neglected. So it will become minus 4RA AQ. A will be neglected, R to the power 4. So it will become minus 4 A KQ divided by RQ. This is the electric field. This is the electric field on the axis. Okay. Now we will follow the same procedure and will calculate the electric field at this point. Our distance away. Due to positive charge and negative charge. Will tell me what is that. Next class. So let me tell you a little. Take it as homework. Do this. Let me know in the next class. And now let me tell you a little about the charge distribution. So there are three kinds of charge distribution. One is the line charge distribution. It means like if the charge is distributed over the line. If the charge is distributed over the line. And one second, let me tell you one thing also here. Because you got the negative answer, it means the electric field will be in the negative direction. You got here negative answer, right? It means the net electric field will be negative direction, negative x direction. So this is called the line charge. Linear charge density, you can say. Line charge, you can say. Linear charge density lambda is defined as dq by ds. Charge divided by length. There is a surface charge density that is defined as sigma is equal to dq by ds, area. Charge divided by area. If it is uniform charge density, then you can write total charge divided by total area. Here also, if it is lambda uniform, then you can write total charge divided by total length. But if it is not uniform, then you cannot write this formula. Instead, you have to use this formula only. Volume charge. For volume charge, it will be dq by dv. And rho uniform will also be written as total charge divided by total. These are the charge densities. Now let me tell you about the Gauss law also. Gauss law tells you that flux through a closed surface, F phi c, flux through a closed surface, okay, will be equal to charge enclosed by that surface divided by epsilon naught. That is the Gauss law. It is very important. They can ask this Gauss law.
Sir, what have you written in the numerator?
Yeah. Numerical?
Is that Q?
Numerator. Okay. Numerator is Q enclosed.
Enclosed. Okay, sir.
Yeah. Q, E, and C. Sorry, my writing is a little bad. So Q enclosed, E and C.
Sir, the C indicates the current.
Which C?
The high C, the formula. Yeah, yes, sir.
It indicates that phi closed. It means the flux through a closed surface. For example, there are open surface means this surface is open. But a surface of sphere is closed because it is enclosing some volume. So if there is a closed surface means it is enclosing some volume. So this the surface of sphere is enclosing some volume, right? The surface of cylinder is enclosing some volume inside. So that are called the closed surface. So flux through these closed surface will be equal to charge enclosed by these surfaces divided by epsilon. That is Gauss.
Okay, sir.
Okay. That's very important. Whatever charge is inside, you will divide by epsilon naught and you will get the flux. So that you can take as a one of the definition also of calculation of the electric flux. Okay. So the rest of we will calculate in the next class, and this is it for today.